Welcome to the class today. Today we are learning about electronics. This is the first of a series of lectures about basics of electronics. So today we are going to define electronics. What is electronics? Electronics is a science, is the field of science and engineering that deals with the flow of electric current, or let's say flow of electron. It deals with flow of electrons. So from electrons, the word electronics is derived. All right. So when the electron flows in different material and it is being controlled, then we talk of electronics. All right. Now, a material can be a mixture of substances, which can be either pure or impure. A material can be a mixture of substances, which can be either pure or impure. It can be biological, it can be non-living materials. And then these materials can be classified according to their physical and their chemical properties. Sometimes you can classify material according to their geological origin or biological function. So in electronics, we talk about the electrical properties of materials. We deal with the electrical properties of materials. Since our interest is flow of electrons, then we are so much interested in the electrical properties of materials. Now, as far as electronics is concerned, we classify materials into three different types of materials. And those are conductors, semiconductors, and then insulators. So as far as electronics is concerned, we classify material into these three broad categories. Now, if you look at these materials, we can classify them based on their group on the periodic table of elements. For instance, conductors, they are metals, materials that are metals, and semiconductors are materials that are on group 4 of the periodic table. They are found on group 4 of periodic table. Alright? So we can classify materials based on where they are found also on the periodic table of elements. Alright? Now, what determines whether a material is conductor, semiconductor, or insulator basically is the way that they allow the flow of electrons to pass through them. That is their conductivity. That is what determines whether they are conductors, semiconductors, or insulators. So conductors, they are materials that allow free flow of electrons through them, whether free flow of electricity or heat through them. While semiconductors, they don't allow free flow until you modify their property a little bit. Then they can allow free flow of electrons. And insulators are generally regarded as materials that is very hard for them to allow the free flow of electrons. Alright? We can classify the conductivity of materials based on these three groups of materials. Now, when the temperature increases, you find out that the electrons are constrained in their movement in conductors. So in other words, with increase in temperature for conductors, their conductivity reduces. That is the behavior of metallic conductors. And then the best metallic conductors, they are materials such as silver. Okay. Now, we have gold, we have copper, okay, and then we have aluminium, we have mercury, we have iron, we have steel. By the way, steel is an alloy of iron. Alright? Okay. Now, the use of silver and gold in electrical works, in electrical application, is very rare because these two are very, very expensive. Due to their high costs, they are not really used in electrical materials. Alright? So the common one you find are copper and aluminium. Those are the commonest in as far as electrical conducting materials are concerned. Copper and aluminium, they are the most often used. Alright. One important means of classification of materials into these three groups is the atomic structure they exhibit. Okay? So we use the atomic structure to classify materials into whether conductors, semiconductors, or insulators. So that is what forms the classification. And then we want to talk about first conductors. What kind of atomic structure insulators have. So we look at the type of atomic structure. For conductors, they allow free flow of electrons because there's a large number of mobile charge carriers, that's free electrons that form charge carrier. So that is why they are conductors. They can easily convey a free flow of electrons because of a large number of free electrons at their outermost shell electrons. Okay. For instance, metals, they have low energy electrons which are sufficiently detached from their atomic structure and making conductivity possible. Metals have these free electrons that are of low energy and can easily get out of their atomic structure and form a large number of free electrons that convey free flow of electron or flow of electricity in the material. So, and that's why they have high conductivity. But another important thing is that the conductivity of conductors largely depends on temperature. With higher temperature, the conductivity of conductors reduces with higher temperature. This is because higher temperature causes agitation of electrons in the atomic structure. And then when the temperature increases, the atoms become stronger and the electrons are constrained in their movements. For that reason, they impede the flow of free electrons. And this makes the conductivity of metals to reduce when temperature increases. Increase of temperature does not result into increase of conductivity of metals. Increase of electric conductivity does not result with increase in temperature. Okay, so increase in temperature results into an increase in temperature increase results to increase in resistance increase or resistivity, increase in resistance. Increase in temperature results to increase in resistance for conductors. So this is the basic property or characteristics of conductors. So that's what distinguishes conductors from other materials. And this property is regarded as positive temperature coefficients of resistance. Metals exhibit a positive temperature coefficient of resistance. When temperature increases, their resistivity increases. So they do not conduct more, but they conduct less. Let's talk about the areas that have conductivity. Their own conductivity is lying between conductors and insulators. Their property of ability to convey free flow of electron is lying between the nor insulators. Okay, so semiconductors, they exhibit covalent bond. Semiconductors exhibit covalent bond. Covalent bond. Alright? They have crystalline nature. And because of their crystalline nature, valence electrons are shared between atoms. And the sharing of these valence electrons make it more difficult for materials to move their electrons into the conduction band. So it's not really easy for semiconductor materials to conduct electricity. Alright? Now the commonest type of semiconductors, they are silicon and germanium. These are group 4 elements on the periodic table. Silicon and germanium, they are the commonest example of semiconductors. Alright? So apart from silicon and germanium, there is also a compound, gallium arsenide. From gallium and arsenic, a compound made of gallium and arsenic. It's also another example of semiconductor. Alright? Now, semiconductors like silicon and germanium, they contain covalent bonding so that adjacent atoms share electrons to form a covalent bond. So we have electron here, another adjacent atom, we have another electron. So they share the atomic shell electron to form a covalent bonding. So that's the example of structure of the atomic shell electron. So they don't really conduct electricity like conductors, but not as bad as insulator. Reason being that when energized slightly, there could be movement of electrons breaking out of their covalent bond, and then they move into conduction band, making semiconductors become conductors at that point. This can happen by introduction of heat or some other means, such as doping, which we are going to learn in the future. Alright. So that is about semiconductors. So we want to talk about insulators. Insulators are materials that are a bad conductor of electricity. In other words, they have very high resistivity. Very high resistivity. High resistivity. So they don't allow a free flow of electricity or free flow of electrons through them. Okay. So insulators exhibit either atomic bonding or ionic bond. They exhibit either atomic bond or ionic bond. Now, for atomic bond, the non-metal share electron pairs. They share electron pairs, and so there are no free electrons, which might serve as a carrier of charges. No free electrons to serve as charge carriers. Now, for ionic bond, ions are arranged in a grid network, and then the particles are held together by electrical forces. So, for that reason, there are no free charge carriers to enable a current flow. And that is the reason why insulators are bad conductors of electricity. So, they exhibit either atomic bond or ionic bond. Ionic bond. For the two, there are no free electrons to serve as charge carriers to convey electricity or convey a flow of current through them. That is why insulators, they are bad conductors of electricity. Alright? They are bad conductors of electricity. Okay,